Hello, I'm Travis Smith, Chief Architect of the Weather Company. I'm here with Torsten.
Hello, this is Torsten, and I'm Cloud Data Lake Architect in the IBM Cloud.
We're here to talk about how the Weather Company teamed up with IBM Cloud Services to deliver the COVID-19 data lake in a matter of days, weeks, but not months. Actually, we built our MVP in 8 days, rolling this out into production in a limited fashion, and then getting to the COVID-19 data lake full-blown production in 2 weeks. You may be asking, why the Weather Company? Why would they build a COVID dashboard or a COVID data lake? The answer is our scale. We have over 300 million monthly active users and 40 million users use our app daily. What to wear, what the weather is, whether the council event. We send out billions of alerts every year. We have billions of video views every year. And even we have billions of API calls every single day. So why the Weather Company? Our scale. We want to be essential. Keeping people safe during times of natural disaster is part of our DNA. It's who we are. We've been doing this since 1984, at the beginning of the Weather Channel. We've helped people through hurricanes. We've helped people through tornadoes, winter storms, and all sorts of other national disasters worldwide. So it's a no-brainer that we would do this, that we would use our brand, our reach, our location data to provide all the essentials necessary to keep people safe, even during times of a pandemic. We are a location company. We want to give our users easy access to the COVID-19 data down to the local level. Finally, we do everything with speed. We go to the market really fast. We have high velocity, and it's second nature to us. Anytime there's a hurricane, we storm together, we get together in a room, and we work delivering new products sometimes in the middle of a storm, just so we can get all the information to our users very easily. And COVID-19 pandemic is no different. So what do we need to build? That's the question. We don't necessarily start with, hey, we want to gather data and see where that data takes us. Instead, we want to see what the users want, and we want to ask the questions, what do we need to build? First, we want to build the COVID-19 hub, a central place on the web that everybody can go to, including their location, whether it's a city, a county, a state, or a country. Globally, people can go there and see what the COVID crisis looks like in their neighborhood. Very early on, we built our chatbot on a rudimentary data set using several trusted data sources within the US to provide an interactive experience for those in the United States. Also, we built an interactive map. There are plenty of other people that had lots of other maps with lots of other data, but we wanted to provide our data from trusted data sources, whether that be local health government agencies, etc. And we wanted to build a way for people to consume this in a map format so they can dive in and out to their delight. And finally, we wanted to build out a statistical dashboard. This would be built on Cognos Analytics led by Tony and Samwang and their leadership to deliver COVID data to everybody to use and make conclusions however they wish. This would also use the data lake that we would later build as a part of the TWC pipeline and the COVID-19 pipeline and data lake. So what do we need to get there? We need data, not that data, that data. You need data collected from trusted health organizations like the WHO or the CDC. And we also needed health information from state departments, whether that be from New York City, Montreal, Germany, anywhere in the world. We wanted to gather it all from governmental trusted data sources. So we weren't using secondhand information. We were using the real data, real time as it happened. So how do you gather data from disparate places around the world? Well, you don't want to build it on trash or with trash for that matter. Instead, we needed to build a pipeline, a solid pipeline that would go out and get the data from all those places, normalize it, and send it through into the data lake and to the front ends where we can infuse that data into the world. So how do you build a stable, secure pipeline that can scale? First, we use agile methodology in its purest forms, and we hit tight deadlines, meeting 2-3 times a day in all the agile ceremonies. We typically normally storm together in a war room, but we had to do it virtually because we're all working from home as a result of the COVID pandemic. So we swarmed the problem. We were a truly cross-organizational, cross-business unit team. As Yamamoto says, the fiercest serpent can be overcome by a swarm of ants. And that's what we did. We took this fierce problem of the COVID pandemic and we swarmed it to overcome it and deliver our COVID dashboard MVP in 8 days, and then delivered the COVID data lake at production scale in a matter of weeks. In order to do this, we had to have speed. We had to have scale. And we did this on IBM Cloud using object storage, cloud functions, and event streams. And it looked kind of like this. We would go get our data from various location and places. We would pipeline it into the landing zone and preparation zone and through our pipelines using cloud object storage and events triggers to cloud functions. From cloud functions to Kafka and event streams. And then from there to various databases and into the data lake to be exposed and infused around the world through the weather API, through the chatbot, through the Cognos dashboard, as you see later, and then even more products to come. Next, Torsten will go into further detail to explain and to reveal how the weather company and IBM Cloud built the data lake from this simple high-level overview to something more useful to be used by various teams, whether the Cognos team, Data AI, or the Watson Health teams, to deliver even more products today. Now to you, Torsten.
Thank you very much, Travis. So you've just seen the overview of this end-to-end solution for collecting and analyzing COVID-19 data by the weather company. So step one, as we have seen, is really just a collection of this data and making it also available to users in an interactive map. This is the URL we can see here. And now step two, and that's where I want to basically spend a bit more time here, that is running in the solution, is really taking this data and making it available for advanced analytics and generating advanced insights. For that, we also need a very scalable and very agile solution stack to store this data and make it available for analytic processing. And we had to build this also in a very short turnaround time because the pandemic is a very dynamic situation that we had to respond to very quickly. So we were looking at also some options here, like for instance, a data warehouse. Can we use a data warehouse for that? But especially because of the short turnaround times and the requirement for building this out very quickly, self-service with a handful of developers, we decided to use the IBM Cloud Data Lake solution, which is especially geared towards a serverless solution stack, which allows us to build such things very quickly with minimal effort and minimal time. So what we built out is this data lake here, and it consists, as you can see here, of 4 major cloud services of the IBM Cloud that we were using to build it. And they are all geared towards self-service and serverless consumption and application design in order to achieve maximum velocity and really build a new pipeline of new data within very few days and bring it to production. So those 4 services that I'm going to show you in the following are: one is the cloud object storage, which is our storage option for all kind of data in the IBM Cloud, highly resilient, highly affordable, highly available. And we obviously use it to persist this data, but we also use it for other things in the data, like for instance, automation. We basically had to automate the pipelines whenever new data arrives in object storage. The object storage is able to trigger a processing, an event basically that triggers processing. Now, what is this processing actually about? That is what Cloud Function actually enables us to do. Cloud Functions is a serverless runtime service on IBM Cloud that we use for many different purposes in this data lake. Of course, also for basically running and automating data transformations and pipelines. But we also use to do some operational integrity, like for instance, monitoring the data lake itself, generating alerts when problems arise. And we also use it to pull in code that we had to run for pulling, for instance, external data. So that is basically custom code that needs to run here. But the actual heavy lifting of the data itself, especially the data transformations of this COVID data, is actually happening in another service that is called by the Cloud Functions, which is our serverless SQL service. It's called IBM SQL Query, which is a scale-out Spark-based SQL service that runs entirely serverless from a user's perspective and can transform data of any kind. And also transport data, for instance, from object storage buckets to one another, or from object storage to a database if needed. We also use it to maintain the data model of this data lake. So it comes with a data table catalog, an embedded Hive metastore. And we also use this service in order to give users access to the data lake. When they want to query data in the data lake, they also use that service. And for the whole development process, another service also has been very important, which is Watson Studio. In particular, we are using the notebooks feature of Watson Studio in order to do multiple things. One is to prototype new pipelines very quickly. I'm going to talk about that in a second. But also to do certain operations of static content, things that only need to run on demand, like for instance, certain metadata when that needs to be updated. We run this through notebooks in an interactive fashion on demand. But we're also using Watson Studio in order to enable users of the data lake to interact with the data and understand the data lake's content and data model, basically by publishing notebooks for tutorials for that. So those 4 services are the basis for that we're using. And now the question is, what's the process, how we use that? And what we came up with is a best practice of using these services. We call it the 4 Ps of serverless pipelines. And those 4 Ps are on one side Python. Python as basically a language that is very accessible for many data engineers and developers in order to interact with the data of the data lake. So that happens on one side on the object level, really by having the libraries in Python to interact with the objects on the object storage, but also inside those objects we have data and we need to look into that, and we just use another Python library in order to run those SQL statements and interact on the SQL level with the data in these objects. With that, we started off to prototype pipelines first, and that's where, for instance, these notebooks come in very handy, because you can just go to a notebook in a very interactive and collaborative fashion and write a few cells of Python in order to build your first experimental pipeline of taking data that has been collected and now transforming it into data that should go into a data mart, the data lake that is used for analytics. So that enabled us to be very quickly, within a few hours, we had new pipelines running or produced as a prototype in notebooks. And the next step was we went to a POC. So that's the number 3 P here. Which just means we automated this notebook by just scheduling it. Another nice feature of Watson Studio that you can just use, just basically set up a schedule that this notebook should run automatically. And then we could basically see whether this pipeline really does what it's supposed to do in the long run. And the next step is really the productization that we went on, the number 4 here of the P, which we just take exactly the same code that we just created and POC'd with automating notebooks and putting it into Cloud Functions. And Cloud Functions are basically a serverless way of running, for instance, Python code very nicely. So that's basically the process that we employed here. And we ended up building a topology like this. So this is now our detailed topology of this data lake that we have built out. And you find all of those services here again, like, for instance, the functions that are basically running here on different zones of this data lake. They are using the SQL query instance to run certain heavy lifting processing on the data. And you also find the Watson Studio projects here. And at the bottom of this, we have object storage, also just divided in zones, which is a very typical thing that you find in data lakes, that you distinguish between the landing zone, where the raw data comes in. Then you have a preparation zone, which is another set of object storage buckets that we used in order to work with the data. We prepare it, and then finally we put it into integration zone. And that's really the data now in the integration zone that we also expose to consumers of this data lake. Dashboards, applications, users that work with the data interactively. For that, you can see here there's another special SQL query instance which contains this table catalog. So that's the externalized table model, data model of this data lake. So what you have just seen is basically a purpose-built data lake that we built out for this data for COVID-19 as part of this TWC overall data collection pipeline infrastructure. But these services that we've just shown to you are actually part of a bigger stack in the IBM Cloud. And I just wanted to also give you a chance to see this in a broader context. So you see here our so-called ladder to AI of our data and AI portfolio in IBM Cloud. And basically a data lake and the services we have just seen are primarily taking care of in the first phases of this ladder to AI. So we can see these phases are collect, organize, analyze, and infuse. And especially in the collect and organize and partially the analyze phase, these data lake services play an important role. Then on top of that, then come higher value services like, for instance, dashboarding services, Watson AI services that are then built on top and using these data lakes and the data in the data lake. But the core of this whole thing that enabled us to be so fast and in a very short turnaround time, really within a few days, build this thing out and get it into production was really the serverless nature of these key components. And I just want to basically repeat them once more explicitly. So the three key serverless components are serverless storage, IBM Cloud Object Storage, which scales seamlessly and also from a business side of things also scales fairly because you only pay for the volume of the data that you really store. Then we have serverless runtimes. This is the IBM Cloud Functions, which scales seamlessly and where you also only pay for exactly what you're really executing. The CPU time basically is measured here. And the third big component is the serverless analytics, which is this SQL query service here that basically runs a full Spark stack for you under the hood on demand in a serverless fashion. And also here you only pay for what you really scan, the data volume that these SQL statements and SQL ETL jobs really had to scan, only that is charged. And what this enables at the end is really an empowerment for solution developers and solution owners. Because with that, you basically can give data producers, like in our case here, the TWC data solution, the TWC solution stack is now enabled very freely without having to basically work with a lot of separate experts like data engineers to build out such a data lake very, very quickly in very short turnaround time. And basically this fosters a transition that is also basically a trend that you find in the industry nowadays from mere data producers, where data often is just produced and a separate team will have to understand it and basically prepare it for insights, to really data product owners. So they can really be the owners of the analytic data product directly. So one of the things, it goes beyond what we've just seen with the TWC that is enabled with that. So that's a thing that also IBM now brings to the table here is other higher value solutions. One of the things that you can see today already is the Watson Health Return to Workplace Advisor as a solution that is built on top of this data that has been built out within very few days, this infrastructure for COVID-19. And now we are going to the next step to really build high-value solutions like, for instance, this Watson Health Advisor here. Thank you very much for attending. We are at the end of this session. Thank you very much for your interest. Also, thank you very much, Travis. And I hope you have seen how quickly it is possible to build such a solution. And we invite you to follow up with the resources that we provide to you here in this deck. There are certain links. Please follow up. Please go to IBM Cloud and try this out to yourself. And I'm confident also you will be able to build out such a data lake solution yourself in such a short turnaround time, just as we could do this here together with the Weather Company. Thank you very much.